Good morning. Today we discuss integration of some trigonometric functions. Okay. Before we discuss about that, we remember the trigonometric formula sin alpha plus beta plus sin alpha minus beta is equal to 2 sin alpha into cos beta. That means like 2 sin alpha into cos beta is equal to sin alpha plus beta plus sin alpha minus beta. So sin alpha into cos beta is equal to 1 by 2 sin alpha plus beta plus sin alpha minus beta. Similarly, we can find cos alpha into sin beta, that equal to 1 by 2 sin alpha plus beta minus sin alpha minus beta. Also we know cos alpha minus beta plus cos alpha plus beta is equal to 2 cos alpha into cos beta. That implies 2 cos alpha into cos beta is equal to cos alpha minus beta plus cos alpha plus beta. So cos alpha into cos beta, we write 1 by 2 cos alpha minus beta plus cos alpha plus beta. Similarly, we can find sin alpha into sin beta is equal to 1 by 2 cos alpha minus beta minus cos alpha plus beta. Okay. Now we discuss about the integration of some trigonometric functions using these formulas. Integration of some trigonometric functions. Okay. If the integrand that means which integral we require. If the integrand is of the form sin mx into cos nx or sin mx into sin nx or cos mx into cos nx. A trigonometrics, then a trigonometric transformation will help to reduce it to the sum means addition, sum of sine function or cosines of multiple angles which can be easily integrated, which upon multiple angles which can be easily integrated, Suppose sin mx, if the integrand is of the form sin mx into cos nx or cos mx into sin x, whatever it is. So we write the sin mx into cos nx as 1 by 2 into 2 sin mx into cos nx 1 by 2, you know, sin mx 2 sin alpha into cos beta is equal to sin alpha plus beta plus sin alpha minus beta. So we write here sin mx plus nx plus sin mx minus nx. Okay, that equal to 1 by 2 sin m plus n whole x plus sin m minus n whole x. Also you can write it directly 1 by 2 sin m plus nx plus sin m minus nx. So the integration of this function is more easier than the sin integration of sin mx into cos nx. So we write it sin mx into cos nx, that implies sin mx into cos nx is equal to 1 by 2 whole into sin m plus n whole x plus sin m minus n x. Okay. Similarly, if the integrand is of the form sin mx cos mx into cos nx, okay, then we write a 1 by 2 into 2 cos mx into cos nx. Also here write 1 by 2 into cos mx plus nx plus cos mx minus nx. So here we write 1 by 2 cos m plus n whole x plus cos m minus n whole x. Okay. Similarly, if we so that implies cos mx into cos nx, that equal to 1 by 2 whole into cos m plus nx plus cos m minus n x. Okay. Similarly, if sin mx into sin nx, you know, sin alpha into sin beta, that is 1 by 2 into 2 sin mx into sin nx. You know, 2 sin alpha into sin beta is equal to cos alpha minus beta minus cos alpha plus beta. So we write here 1 by 2 cos mx minus nx minus cos mx plus nx. So 1 by 2, that cos m minus n whole x minus cos m plus n whole x. Okay. So sin mx, so sin mx into sin nx is equal to 1 by 2 cos m minus n whole x minus cos m plus n whole x. Okay. Similarly, if the integrand is the product of three factors, more than 2. In case of more than two factors, in case of more than two factors, a successive transformation will help. A successive transformation will help. For example, if the integrand is of the form sin mx cos nx into cos kx, okay, sin mx into cos nx into cos kx, then you can take cos nx cos kx as one factor or sin mx cos nx as one factor. Here we take cos nx cos kx as one factor, so we write it in the form sin mx whole bracket cos nx into cos kx, so that equal to 1 by 2 sin mx into 2 cos nx into cos kx. So 1 by 2 sin mx whole into cos nx plus kx plus cos nx minus kx. So we write that equal to 1 by 2 sin mx cos n plus k whole x plus cos n minus k whole x, that equal to 1 by 2 sin mx into cos n plus k whole x plus 1 by 2 sin mx into cos n minus k whole x. Here we put sin alpha into cos beta, that equal to 1 by 2 whole into sin alpha plus beta plus sin alpha minus beta. So we put that equal to 1 by 2 whole into 1 by 2 sin mx plus n plus k whole x alpha plus beta plus sin mx minus n plus k whole x, also plus 1 by 2 whole into 1 by 2 sin mx plus n minus k whole x plus sin mx minus n minus k whole x, okay, that equal to 1 by 4 sin m plus n plus k whole x plus sin m minus n minus k whole x plus 1 by 4 sin m plus n minus k whole x plus sin m minus n plus k whole x, okay, that equal to 1 by 4 sin m plus n plus k whole x plus sin m minus n minus k whole x plus sin m plus n minus k whole x plus sin m minus n plus k whole x. Okay, so this is more convenient to integrate than the function sin mx into cos nx into cos kx. Now we take some examples from your exercise 9C. Example exercise 9C number 1. I evaluate integral sin 4x into cos 3x dx. Answer. Now sin 4x into cos 3x dx, that equal to, we write sin alpha into cos beta. You know 1 by 2 sin alpha plus beta plus sin alpha minus beta. Here in place of alpha put here 4x, in place of beta here 3x. So that is 1 by 2 sin 4x plus 3x plus sin 4x minus 3x dx. Okay, that equal to 1 by 2. We take the constant 1 by 2 out of the integral sign. So 1 by 2 integral sin 7x plus sin x whole dx. Okay, so 1 by 2 integral sin 7x dx plus 1 by 2 integral sin x dx. So 1 by 2 into minus cos 7x divided by 7 plus 1 by 2 into minus cos x. The integration of sin x is minus cos x. Integration of sin 7x is minus cos 7x divided by 7. That from the formula sin ax plus b. You know the integral of sin ax plus b is equal to minus 1 by a cos ax plus b plus c. We write, so that the integral becomes minus 1 by 14 cos 7x minus 1 by 2 cos x plus c. Okay, now we take another example from your exercise 9C 1b. Evaluate the integral of cos 4x into cos 5x into sin 2x dx. Okay, cos 4x into cos 5x into sin 2x dx. Here we take a cos 4x into cos 5x as 1, or sin 2x into cos 4x as 1, or sin 2x cos 5x as 1. So here we take cos 4x. Now we arrange it as a sin 2x whole into cos 4x into cos 5x whole dx. So integral sin 2x, that is cos alpha into cos beta. 1 by 2 cos alpha plus beta plus cos alpha minus beta. So we write here sin 2x as sin 2x, in place of cos 4x into cos 5x, we write the 1 by 2 whole into cos 4x plus 5x plus cos 4x minus 5x. So that we take 1 by 2 from integral sin 1 by 2 whole integral sin 2x, that is cos 9x plus cos minus x whole dx, that equal to 1 by 2 integral sin 2x cos 9x plus cos x whole dx. The cos of minus theta is equal to cos theta in trigonometry. So we write that equal to 1 by 2 integral sin 2x into cos 9x dx plus 1 by 2 integral sin 2x cos x dx. Okay, here we put sin alpha into cos beta. Sin alpha into cos beta is 1 by 2 sin alpha plus beta plus sin alpha minus beta. So we write 1 by 2 whole into sin 2x plus 9x plus sin 2x minus 9x whole dx plus 1 by 2 integral 1 by 2 sin 2x plus x plus sin 2x minus x dx, that equal to 1 by 4 integral sin 11x plus sin minus 7x whole dx plus 1 by 4 integral sin 3x plus sin x dx. Okay, that equal to 1 by 4 integral sin 11x minus sin 7x. Sin of minus theta, that equal to sin minus sin theta plus 1 by 4 integral sin 3x plus sin x whole dx. Sin of minus theta, that equal to minus sin theta. Using this formula, we write sin of minus 7x is equal to minus sin 7x. So now separate 1 by 4 integral sin 11x dx minus 1 by 4 integral sin 7x dx plus 1 by 4 integral sin 3x dx plus 1 by 4 integral sin x dx. So 1 by 4 into minus cos 11x divided by 11 minus 1 by 4 into minus cos 7x by 7 plus 1 by 4 into minus cos 3x divided by 3 plus 1 by 4 into minus cos x plus c. That's the integral of this function. So we write minus cos 11x divided by 44 plus cos 7x 28, 4 into 7 minus cos 3x divided by 12 minus cos x divided by 4 plus c. Okay. Next we discuss if the integrand in the power form of a trigonometric function. In the power form of trigonometric function, suppose when one or both of the powers in the one or both of the powers in the integrand, like sin mx into cos nx, sin to the power mx into cos to the power nx is an odd positive integer. 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 There is a more convenient way for there is more way for integration convenient way for integration. If n is odd, in the product of sin to the power mx into cos to the power nx, suppose n is an odd integer, odd positive integer, then keeping one cosine factor, one cosine factor, which is the derivative of a sine, keeping one cosine factor and the remaining even power of cos x, keeping one cosine factor, the remaining even power of cos x. Suppose cos cube x, so we keep cos x, the remaining cos square x, even power of cos x can be converted to sine function, can be converted to sine function. Suppose here cos cube x, then we write it in the form cos square x into cos x. We change cos square x 1 minus sine square x, converted into sine function. Okay. Then we get a polynomial. Then we get a polynomial in sin x with the derivative of sin x with the derivative cos x, which is the derivative of sin x, with the derivative of sin x. Okay, with the derivative of sin x. Yes, then we put sin x as one variable, so t. A substitution for sin x will help to integrate the given function. Okay. Similarly, if m is odd, keeping one sine function, or factor, one sine factor, the remaining even power of a sin x, the remaining even power of sin x, can be converted to, suppose, sin to the power qx. Then we write sin x into sin square x in place of sin square x. We convert it to sin square x in the cosine form, 1 minus cos square x. Okay, sin x can be converted to a polynomial in cos x, polynomial in cos x. Okay, and a substitution for cos x and a substitution for cos x may be made. Then we can easily integrate it. Now take an example from your exercise 9c. Exercise 9c, number 2, bit b triple a. Integrate sin to the power 20x cos qx dx. Okay, answer. Integral sin to the power 20x into cos qx dx. Here cos qx, the power of cosine function is odd, so we write sin to the power 20x into cos square x into cos x dx, keeping 1 cos x. Now we convert cos square x as a sine form. Sine to the power 20x, you will need to 1 minus sine square x into cos x dx. So we get a polynomial in sine with derivative of a sine cos x. Put to sine x is equal to t, that is d by dx of sine x, that equal to dt by dx. That implies cos x is equal to dt by dx, that implies cos x dx is equal to dt. So the problem becomes t to the power 20 whole into 1 minus t square dt. In place of sin x we put t, cos x dx we go to dt. So we write in that equal to integral t to the power 20 dt minus integral t to the power 22 dt, that equal to t to the power 21 divided by 21 minus t to the power 23 divided by 23 plus c. So we write sin to the power 21x divided by 21 minus sin to the power 23 divided by 23 plus c. Okay. Now take another example from your exercise. Integrate number 2 VII, integrate cos to the power, integrate cos to the power 5x into sin to the power 3x dx. Here both are odd power. Sin to the power 5x cos to the power 5x into sin cube x dx. Here we write integral cos to the power 5x into sin square x into sin x dx, that equal to integral cos to the power 5x whole into 1 minus cos square x into sin x dx. Put cos x is equal to t, that implies d by dx of cos x, that equal to dt by dx. Okay, you know the derivative of cos x is minus sin x, that equal to dt by dx. We write sin x dx, that equal to minus dt. So that it becomes t to the power 5 whole into 1 minus t square minus dt. So we write that equal to minus integral t to the power 5 dt plus integral t to the power 7 dt minus t to the power 6 by 6 plus t to the power 8 by 8 plus c, that equal to minus cos to the power 6x by 6 plus cos to the power 8x divided by 8 plus c. Or we write it as cos to the power 8x divided by 8 minus cos to the power 6x divided by 6 plus c. Okay, thank you.